Good morning, good afternoon, everybody. And I'm very excited to be part of this workshop. And thank you, organizers, and especially my colleague Andrea Stecanella and Marco Darin for the opportunity. So I thank you for the introduction, Helmut. But I'm as you said, I'm the senior technical specialist from Stellantis. I'm based out of Auburn Hills, near Detroit, which is our North America headquarters. And I'm responsible for cybersecurity and over-the-air updates in our connectivity organization. Yeah, so today the topic is connected cybersecurity architecture for connected vehicles. So this is an extremely broad and wide area, right? So I'll try to touch on the essence of it, which would be pretty high level, right? But I'll try to do my best in the next 20 minutes. So here we will touch upon the vehicle attack surface and connected vehicle services as we know now, and also the cybersecurity strategy. And we'll look at the future electrical and electronics architecture trends, and also take a look at the connected vehicle architecture of the future, as well as the cybersecurity challenges for connected vehicles. And we'll move on to the Q&A in the end. Is this slide visible? You're seeing the big screen, right? Just want to make sure.
Yes, it's working. Very good.
Okay, great. Yeah. Okay, so this is probably a familiar slide with vehicle attack surface. So you would see, wired as well as wireless interfaces. And, this is what we all know is part of the modern vehicle, right? Which is called as a computer on wheels, which means, why do they call it? Because we have powerful CPUs running commercial grade operating system and interfaces like Bluetooth, Wi-Fi, cellular, NFC, ultra wideband, you name it, it's there. Now we are talking about cellular V2X, DSRC, right? So as you know, these interfaces are what enable powerful services for our customers, but this also creates opportunities for the bad guys, right? Like for the attackers. So it is very important, for us as auto manufacturers to make sure that all these interfaces are secured, which is a challenge, right? And if you look at the computer, the NIST definition of cyber physical systems is probably more accurate than just calling it a computer on wheels, because this is a system that integrates computation, communication, sensing, and actuation with physical systems, and to fulfill time-sensitive functions with varying degrees of interaction with the environment, including human interactions. So this is a mouthful, but what we are trying to say here is, you have very good, heavy computation power combined with multiple external interfaces, which and you can also control, what the vehicle is going to do. So there is a lot of implications to this, which means, we have to analyze each of these attack vectors and make sure they are mitigated or contained, right? So, so the takeaway from this slide is, while all these, so, okay, one second. Yeah, while all these services are, enhancing driver experience for the users, we are also increasing the vehicle attack surface.
Sorry for interruption. Maybe you should be seeing now the wrong screen. We now see only the Teams.
Oh, really? Okay. I
Sharing.
think something happened when an admit happened. I think somebody entered the lobby.
Yeah, you're right.
Okay, I'll try to present again. Yeah. Let me know if you see it.
Works again. Very good. Thank you.
Okay, no problem. But okay. Okay. Yeah, so moving on to the next slide. Okay, that worked. So here I wanted to touch upon the connected services architecture today, which might be familiar to most of you. But basically, you can see that there are not too many actors here. So let's start bottom up. So we have the the vehicle layer, right? So we have vehicles, and we have OEM cloud, we have third-party cloud. And of course, you have the cybersecurity infrastructure on the right, and security services. So vehicles, talk to the third-party cloud or the OEM cloud, depending on what services are need to be fulfilled for the customer. So over-the-air updates or diagnostics services, right? You go to the OEM cloud, and you also have third-party services, that your customer will want, because they expect to have a lot of services, that are available on your phone to be available in your car as well. So you'll need integration with some Google services probably, or Amazon, or other services that are provided by not the OEM but other third-party services. So from a cybersecurity perspective, we want to make sure that the vehicle and the people are secure and their privacy is not compromised. This means the vehicle components and connected services do not compromise, authenticity and integrity of the system while maintaining availability. What does that mean, right? That means that we have to make sure the firmware on the ECUs are secure, and they are, which means they are authentic, and the updates are authorized, right? You don't want any firmware, anybody modifying the firmware here and doing random things, right? And you also don't want to make sure that whatever data is sent outside of this vehicle don't reach the wrong hands, and the privacy is maintained. So how do we do this? Like, there's we'll talk about that in the next slide, but we also need supporting cybersecurity infrastructure in addition to what you do in vehicle, right? Because if you are doing crypto, you'll want to make sure that there is a cybersecurity infrastructure that is available at the OEM side to support these the authentication and authorization services. Okay. Yeah, so as you can see, the cybersecurity and privacy in this model is focused on ECUs, or I can say component based, as well as the OEM cloud based cybersecurity. So talking about how do we do this? Let's talk about what is the high-level security strategy commonly employed today, right? So we have, like I said in the previous slide, the cybersecurity strategy is very component-centric. It is component or vehicle-centric with extension to the cloud, which means for every ECU, we need to make sure that there is a cybersecurity strategy. So this is a high-level implementation, high-level strategy employed commonly. So you'll start with the at the very core you have a hardware trust anchor or a secure element, which is storing your keys. By the way, not all these layers need to be there in all ECUs, right? So depending on the complexity of the ECU and what functions it is providing, you may have a few layers less. For example, like an infotainment ECU will need to have an application sandbox, which is probably not required on a body controller. So so it's not like you need every one of these layers. You don't. It all depends on what is your attack vector, and then how do you what is essential for you to maintain the required security levels. So you have kernel level protection, operating system with discretionary and mandatory access control, You'll have like software authentication framework, secure. If you want to debug, how do you do it securely? Firewall, and also secure framework for doing application isolation. And how do you expose the APIs to the external services, and how do you control access to critical information, right? And you also need to have a secure vehicle architecture, which means you probably need to have firewalls. You need to have a gateway, so you protect your core components, intrusion detection, prevention system. You'll need to have logging and monitoring and control. All of these are required. And you also want to make sure that between ECUs, the messaging is authenticated. So you want to, if a message is coming from ECU1, ECU2 need to be able to make sure that it is coming from an authentic source within the vehicle. So you need to have a strategy for having that in place. So in a nutshell, a vehicle and ECU centric is the cybersecurity mechanism here. Do I need to pause for a little bit to read this? Can I move on?
Yeah, move on.
Okay.
Thank you.
Okay. Yeah, no problem. So Will, I wanted to bring up this slide. It's a transition slide to connected vehicle architecture. So I wanted to talk about how the EE architecture is evolving. So as of now, we have this kind of architecture, like this, the traditional architecture or a domain controller architecture is what we have today, and this is the architecture of tomorrow. So the distributed architecture, this is ECU centric, and which means an ECU has its functionality, and there is a central gateway for cross-domain communication, and it's signal oriented. Whereas in domain controller architecture, you go one step above, and you say that you want to do a functional consolidation in domain ECUs. So you could have a display domain, you could have an infotainment domain, maybe an ADAS domain, things like that. So here there is more widespread use of Ethernet and maybe service-oriented architecture. But what we are talking about for tomorrow is centralized architecture that is talked in the industry, right? So what the concept here is, you have a center computer, and you have high performance computation available to you, which can be virtualized. And so you can think of this like a data center, like a powerful computer which is virtualized, and then each of this computer, each of this high performance hardware called HPC, provides caters to certain zones, like the zones within the vehicle. So the idea here is to decouple the software from hardware so that both can evolve independently. And as we all know, software is is how you get services out to customers quickly. So you don't want to tie the software onto the hardware. You want them to evolve independently. I should be able to roll out services quickly without having to worry about hardware changes, which is a lot more costly, and it takes a lot more time. So here the idea is to do the decoupling as well as have the ability to do software reuse using service-oriented architecture that is very commonly used in the cloud for years now. So in this architecture, the idea is to augment the computation power of the cloud through this kind of an architecture. So you will have like cloud or edge. We'll talk about that in the next slide, but we'll have cloud extensions inside the computer that is capable of leveraging the computational capability in the cloud, right? So you have extensions here. So if you have like AD/DA applications that are requiring a lot of computation, you can leverage the computational capacity in the cloud. which today happens on your mobile phone. So it's a similar concept that we are talking about for the vehicles. So basically what is happening is, as the architecture extends to the cloud, so does cybersecurity and privacy. So this makes cybersecurity concerns, or the idea of cybersecurity, now becomes more complex, and it extends, all the way to how the architecture extends. So this is the, the main slide of my presentation, where I wanted to, put all the thoughts here together, where I wanted to show the different different systems at play. So this, if you compare this to the picture of today, this is the connected vehicle architecture of tomorrow at a very high level. So you would see some additional systems. So you'll see, what I've highlighted in yellow are the new or modified systems. And what is in red is, it's outside of OEM, and it's a central agency or policy maker who's doing this. So we'll talk about this, but let's talk about, the boxes starting bottom up. So here, I think all of you are familiar with this V2X communication, right? You know about this. So this is the foundation of, connected vehicle services. So we know V2X and Edge Cloud will enable ADAS and AD. So there is the complexity here from a cybersecurity perspective is, this is the first time an OEM's hardware is, or vehicle is talking to other vehicles from different manufacturers, or roadside equipment, or traffic signals. So yeah, so which is normally outside of vehicles' normal trusted boundaries. So each actor here is broadcasting CAMD and BSM messages depending on the region you are in. You have additional messages defined too. I think the next talk is on CAM security, so I'll leave it there. But yeah, but from an OEM perspective, we need to make sure that our vehicles are provided with constantly changing pseudonym certificates to our vehicles, to make sure that their privacy is preserved while still being able to participate in this ecosystem. And we also need to have, inside the vehicle, we need to have misbehavior detection applications within the vehicle, so as to make sure that there is no foul play, and in case you there are lots of techniques for misbehavior detection that I'm not getting into, but you want to make sure that they are caught and reported to the misbehavior authority. So that's one aspect of it. And moving up, there is the multi-access edge cloud, or people call it mobile edge cloud as well. So the idea here is, in the previous slide, a couple of slides before in this architecture diagram, we talked about applications talking to the OEM cloud. But where is the cloud, right? And nobody really knows where the cloud is. It could be thousands of miles away. And, it's probably not the best option to, handle all the real-time traffic. So, so you'll probably, that's where the concept of local cloud becomes very relevant. And the concept is something similar to what you have in the, the real cloud. So you have something similar here, right? So here is where, you will be able to support your real-time applications, for ADAS, AD, based on the computation provided here. So that's one. So that's something totally new. So we have, this is still an evolving area, and we don't know who's operating this, but we do know that there's something like this is needed, in order to support the demands of the real-time nature of applications and the latency requirements. And of course, you do need access to the cloud, for which can provide you with latest information on, required for teleoperated driving or driving assistance, or OTA. Those are going to be mostly here. But you will need to have some component of this, available in the cloud, wherever you need faster processing. From a cybersecurity perspective, we are still trying to figure out what does this mean for us. What is the security mechanisms needed, because this is a totally new model, right? Because this is probably cutting across multiple OEMs and multiple MNOs, mobile network operators, domain, and who is providing this infrastructure, like the towers, the cellular towers, and all of that. So this is this brings in a new set of challenges for us. Andrea, would you like to say something about application development here? Not sure we have time.
Okay, no, I think this is good. One important thing is that how can we trust this new layer? And I think it is like your next point here on the right. But ideally, there are a lot of players here. We also have a lot of standardization entities trying to regulate what we need in terms of performances, latencies, and also scalability, because at the moment, the cloud resources are somehow under the control of the OEM. But in the next future, if we need to connect such a number of users, we need to be very, very scalable, in the order of thousands of vehicles connected each other to do some difficult tasks like maneuver negotiation at intersections, but also sensor sharing, for example, sharing the video stream from vehicles. It will be very challenging, and we need to trust the data coming from all these actors in the street.
Yep.
Okay, thank you. 2 minutes to close the first slot from your side, please.
Okay, I'll hurry up. Yeah, so on this slide, I also wanted to highlight this regional security authority, which is outside of OEMs, and you'll have regional appointed agencies, who's overseeing the overall ecosystem and the cybersecurity policy for that. So because I have 2 more slides, I'll quickly move on. This probably I can just high level. What I'm trying to show here is now the application processing has become distributed, which means earlier, like OEMs knew where their application is sitting and where it ends and where the cloud starts. So now this whole area becomes fuzzy, like, with the cloud enablers, you need to, so the security strategies also need to evolve to handle this fuzzy boundary. This brings us to our last slide, where I just wanted to summarize the cybersecurity challenges for connected and automated vehicles. So the first one is the extension of trust perimeter within V2X, right? So this requires, like I said, each OEM need to be, need to trust external actors and the data coming from them. So this is a challenge, and we have some security mechanisms for this, but we want trying to make sure this is sufficient. And unique regional requirements, for each region, like United States, Canada, or Europe will have different requirements. And the second one is because the architecture extends seamlessly by design, you have additional challenges. If you want to do the end-to-end protection, but then which means the application all the way from vehicle to the cloud, and that may inhibit packet inspections, right? So, and then now we are talking about virtualization. So all the virtualization challenges now becomes, our concern too for the OEM. And like Andrea said, the unclear edge model. So we are looking at how this is evolving, right? And of course, data privacy concerns, because there's a lot of information shared on V2X messages, and they are protected for authenticity, and there is anonymization. But at the same time, we need to make sure that it is protected against insider threats. Yeah, so vehicles are sharing more than ever, a lot of data with external entities that we need to make sure that all the regional requirements and customers' privacy concerns are addressed. That's all I had, and thank you.